You guys are a pretty quiet group, so let me know, like, if you want more practice, less practice, how you're feeling about this. As we go moving forward, we're going to start looking at some object-oriented concepts. We're going to stay looking at methods and things like that too as we get into our object-oriented concepts. It's kind of thinking about how methods can help us be object-oriented. This morning, I'd like to have you get started by creating a small application. And I don't know, do you want to work with your study group? It's kind of up to you guys. If you want to rearrange with your study group, here's what I'd like. I'd like our program to prompt for information about some sort of audio purchase. You could make it be an audio file that someone's purchasing, or a download, or whatever you would like for it to be. But I'd like for it to have these methods. So in our display instructions method, we want to just display some instructions. Welcome to the awesome audio adventure, whatever. We'd like an input string function, probably where you maybe ask them for their name, or you could ask them, I guess, for their favorite artist, you know, something along those lines, but just prompt them for some sort of string. And then we'd also like a prompt for an integer and a prompt for a decimal. Now, hopefully from the REPL, you could use that as some sample code, because some of that code that we saw in that REPL was stuff that we haven't really covered yet. We're going to focus on kind of the structure of our applications here in this first quarter of the semester, and then we'll look at logic, doing if statements and looping and things like that when we come, when we're done with our first 4 weeks. So let's just keep focusing on that. How can we structure this and use some code that we've seen before, even though we haven't really got in depth in it? Well, I'd like to input some sort of integer. You could make that be the number of songs they want, or the number of downloads they want, or however you want to format your program. And then some sort of input of a decimal. What would be good? The time, you know, if you wanted to ask them how long a recording is, or if you want to ask them what the most they want to spend is, you know, something along those lines. Just so that we have a method that does those 3 things. And then finally, we want to display our output. So in our display output, we want to display the string they gave us, the integer they gave us, and the decimal they gave us. So let's spend, I'm going to set my alarm for 8:30 to see how everybody's doing at that point. And then we'll kind of share some code and look at what each other has. So if you're feeling like this is super easy, look around for somebody who's not. If you're feeling kind of adrift, look around for someone who's not, so that you can get some help and get it done. I'll set my alarm here. Make your space, yeah.
Anything that also knows characters.
We want it to be There's the display instructions method.
So you can make yours better. That's all you need. Everybody gets one. I promise, I know. Don't forget that you've got those rebel assignments that have all this code that you did. So if you have it downloaded, your REPL assignments as you get done, you might want to start doing that because they have a little download button on the screen. You can grab those things and keep them on your OneDrive so you can refer to them. Everybody got this input string method? I'm gonna move it onto the
Input number. I've lost it.
I can't zoom in on that very much since it's in the REPL, but we have this method, our input price method from that REPL, inputs a decimal and validates it as numeric. And then this input rating method, it puts an integer and validates it as numeric. So those two are really good code samples for us for inputting numbers. And as you're building it, do the best you can, and then we'll pull it all together when my alarm goes off. All these dumb pieces. Okay, great. I saw a lot of different people in a lot of different places, everybody thinking, that's what we want. So when we're working with methods and basically any programming language, we're gonna have all these little pieces, right? And sometimes people will look at me and say, there's just all these pieces. Yes, there are. And that's part of what programming is bringing all these pieces together and making them work together and work correctly. And so that's what we've got to do. Now, you guys went and you used Visual Studio and you created a project. And you're like, no big deal. Yeah, you know, it was just a couple weeks ago you came in here and made that for it. I've seen people that after a couple of weeks still couldn't do it, let me tell you. So you're doing good. Okay, then when you created your project, you were like, now what do I do? You kind of thought about it and you got yourself situated. And for the display instructions method, we can just create that method header really in a really simple way. It's not going to return anything. So we use that keyword void to say there's no return, no output from this method. Then our method name with the open and closing parentheses to show this method has no input either. So our display instructions method is kind of like the simplest method header that we could have. Void and the method name followed by the parentheses. Okay, so that's the most basic method that we could have. No input, no output. I say that, but then it actually does write things to the console. So we just mean there is no output internally within the program. Okay, it does write some messages out to the console. So in this method, That's all I did, was just one line statement and said, hello, welcome to whatever program this is. And we'll see that a lot with apps. We might see, you know, a really nice heading for a website, and really small one for mobile apps, but we usually see some sort of intro like that. Now, the way my program is right now, if I run it, it's not going to do anything, right? Let's make sure. I'll press Control F5. See my console screen, nothing. So I need to call that method to actually make it execute. And we know that our main method is the one that is receiving control from the operating system. So we have to put our call to our display instructions method in our main. Now we had this happen before. What's it telling me? Remember? What is it? Static. Because when I'm working with the main has been marked static. So I have to make the methods that the main calls static also. So we didn't get any error message for that. That wasn't a syntax error. The compiler or interpreter here couldn't tell that was a problem until we actually went to run our program. And then it was like, oh, hey, wait, this is a little problem here. You can't do this. Okay, so now I'm gonna try it again. Control F5. And now I see my hello message. So great, I've got my method coded and I'm calling it and it's working. So in our program here, this would be a good place for us to put some comments. Display instructions method. So let's say static because it is called by the main. Void, no output. And in parentheses, I'm going to say return data type because that's what we would put there. And then we have our display instructions, our method name. And then we have the parentheses. And those show that there are no input parameters. Okay, so another thing that we saw that we could do last time, kind of helpful, is if we label our closing curly braces, then we can communicate effectively as to where we are in our code. My pink ones are the end of my class program. We also saw last time that if we rename that, it can be more meaningful to us. And finally, the end of our namespace or solution. So again, with our comments, it can kind of tend to clutter things up. Good things, bad things, trade-offs. Then I asked you for a method that prompts for a string. Now I know I'm going to have to make this static because I'm going to call it from the main. And I want to prompt the user for a string. So my data type that I output from this method is going to be a string. What do we want this one called? Let me see. Input string. Bless you. So we have to use a write line statement to display a prompt. What is your favorite band? I know we could ask them for their name, but we do that a lot. So we'll try something else. And we saw too that we could, bless you, we could do a write command if we wanted, if we want the cursor to stay on the same line while they type. And then we want to return whatever they type. So we'll just read in that line that they typed and return that to our caller. So now when I call input string from my main, I need to use a variable to save that return value, that band name. If I declare my string within my main, that would be a local variable to my main. Local variables. Let's do it. String, fave band. And then we'll say fave band equals whatever they type in for our input string method. Now I'm going to go ahead and put in our output method because I want to start being able to tell what's going on, making sure that things are working. And if I just keep coding and coding forever and I put in that method to input an integer and then I put in the method to input a decimal, if I have a problem, I could end up having to make a lot of changes to correct it. But if I do my testing as I go, hopefully I can minimize any sort of errors and the impact that they'd have. So we want to name that thing display output. I'm kind of going in order with my methods, so I'm going to code it after the end of our input string method. Now this output again is not going to return anything to any main controlling function. It's just going to display things on the screen. So our return type is going to be void. Our method name, display output. Now we are going to have some parameters. So far, we know we're going to need a string of their favorite band. Oops. So I could just write out to the screen, write line, your favorite band. We'll use a parameter and output fave band. Now again, connecting the pieces is what we do, because I could have several different developers write these different methods, and it's the controller code, the tester code, that's going to put all the pieces together. So that controller code, that tester code for this program is our main. So in our main, we've called our display instructions to display those. We've called our input string to get their favorite bands. Now let's call our display output. And we need to give it our favorite band. Do, do, do.
Let's try it. Control F5. What's your favorite band? I don't know. How about and then my display output method works and displays that information. This basic structure is something that we'll use repeatedly, right? Over and over. We're going to prompt users for input. We're going to display that output. That's kind of what we do as developers. In between, we're going to have awesome code where we're figuring out logic and things that we haven't got to yet. But our structure of how things can kind of work together is a lot like this. If you think about it, once you have your skeleton for your basic website, you kind of reuse it. Same thing. Everybody got it okay?
Now, when we go ahead and add in a method to prompt for a numeric input,
we're getting way off. Should be way far from your comfort zone. And if you're feeling comfortable with it, then you're in really, really good shape. Because when we're looking at these methods, they include logic, like I said, that we haven't covered yet. Because the input price and the input rating include while statements. Now, I felt like it was okay to give you those because with your intro to programming class, you know about repeating structures. Now, we haven't actually looked at this code a whole bunch to analyze it, to totally understand it yet. Right now, we're copying and pasting. We're kind of playing like the script kiddies or Google programmers, aren't we? Just grabbing some code and copying and pasting it. And sometimes we can do that. Now, I hope you guys are seeing too, as we do this, that there are levels of being able to just grab a program off the internet, right? Because as you're seeing, hopefully with C#, if you don't know what you're doing a little bit, it doesn't really matter if you grab all the code off the internet, because you're still going to be in trouble trying to figure out how to get it to do what you need it to do. So it's not as easy to cheat as some people would be like, oh, I have to go out there and find it. No. I know that you don't. If you've been able to manipulate it and pull it all together, that's a lot of accomplishment. So I'm going to grab some code here, speaking of which, and I want to do this method that inputs the integer. Now, this code that you're looking at here, right now I'm in 2-0-3, and I am looking at the solution code. Now, the thing about REPL is it doesn't let you get to that solution code until you successfully submit. So you might not be able to see it. But in a lot of the REPLs, I actually have it set to where the next assignment starts out where the previous one left off. So if you go to the next assignment, you can see the code. That's not so much the case with these ones. So let me copy this and get it into Visual Studio so you can see it better. I'm going to put it right after the input string method, keep my inputs together, and it's this input rating. And I'm going to have to fix this because it doesn't match what we're doing. So I think what I'll want for this one, it is going to be input int. That's what our hierarchy diagram said. And let's say how many downloads do you want to buy? I don't need a car type, so I'm kind of changing it. So I'm going to change this 0 parameter to be inside the question there. And instead of using this variable car type, I'm going to make it be downloads. And I'm just messing with this to show you guys that I could put that word downloads right inside that string, because it's not a variable, it's just another string, or I can pass it in like this in a weird way. Now, because I've changed the first prompt, I need to change the second prompt. So let's see what's going on here. This while loop could be considered an if statement. So if this were an if statement, I'm going to kind of read it backwards. First of all, the line is going to be read from the console. It's going to be read by this method that is going to try to parse it into an integer. If it can parse it into an integer, it's going to place the integer into this variable specified by the out parameter named temp. So good number going to end up in this temp variable. If it can't parse it because it's garbage, like it's letters or something, temp instead is going to contain a 0. So C# in this try parse is going to make sure that temp is either numeric or 0. So we've got it wrapped in this while loop here, so that as long as they've entered something that's not numeric, it's going to keep displaying this message to them and prompting them for input. So I want the message to be the same as it was the first time. So I'm going to change, I'm going to copy this. How many do you want? And the comma and the downloads word. I'm going to copy that. And I'm going to paste it down here after the invalid value message. So now it's going to say invalid value, how many downloads do you want to buy? So it'll just be like repeating that initial message. I'm going to fix this comment so that the method name is correct, because when we're commenting, sometimes it can be confusing to others if we leave things out of whack like that. Now, in the REPL, you guys just like breezed through and handled it so well. We had the requirement to create this input method for an integer, and I know one of them, it gave you the code, and then it asks you to copy that and create an input statement for a different data type, a double. So let's do that same thing. I'm going to copy this input method now that we have it set the way we want it. And I'm going to paste it. And then this second one, instead of inputting an integer, I'm going to change it to input a double. Now that means I need to change the word int to the word double in other places in the code. So here where I declare the temp variable, instead of an int, it should be a double. In the while loop, instead of an int try parse, I want to do a double try parse. And then my return statement is in error too, because it says, hey, you made temp a double and you're saying you want to return an int. So I need to change that data type in my method header also to double. Perfect. So we got all the important things changed so that we don't have any syntax errors. But let's change our prompt. Let's see about how much do you have to spend? And I don't think we need a parameter. How much do you want to spend? Now I'm getting rid of the parameter and the comma. And then again, I'm going to update the message that's being displayed if the try-parse fails. So I'm going to copy the how much do you want to spend. And paste it. Now we made a lot of really small changes, so that can cause a lot of syntax errors. So let me know if you've got any squiggly red lines or anything that we need to fix before we try to call these methods, because we want to make sure they're all working before we go hit up our main and try to update that. All good? Now if I were to come in here and create another set of comments like I did for the input string, let's do it for our input double. First of all, it's got the keyword private because we copied it from someplace else. In our code, we haven't been using that a lot. Private is kind of the default, so it would be the same if we left it off. But this is our access level. Private is the default. And that means at this point that if I had code in some other file, it would not be able to access this code. So we want to share our code. Share and share alike. Okay, the next thing, static. Again, only one because it's called by the main. Double is our return type. Input double is our method name. Identifier. Some textbooks specify that more than others. And then lastly, our open and close parentheses. We have no input to this method, no parameters. Now, like I said before, comments can kind of glom things up because it can make it harder to see. So put some more, empty lines or whatever you need around that. Because these comments are really important. These method headers can be hard to get a handle on for a beginning C# programmer. And if we start really identifying what each word is of that method header, then they become real easy. We just have to get to know them. Okay, so beautiful. Now we need to call these things that we've created. We have our new input where we can use an integer and one where we can use a double. I want to show you things. So let's go up to the top of our class. And in our main, we created this local variable to hold our band. Well, let's try something else. Let's create a class level variable. So notice where I am. I am in the class part. I'm within the opening and closing curly braces of my class statement, but I am not within any method. So I'm just out in the world in my class. So these class level variables, we can kind of think of them as global variables. They're global to the class. Everything in my class is going to be able to access them. So I think I'll create an integer called, what did we decide we were going to prompt them for? I can't even remember. Oh, number of downloads. And then we want to create a double that is how much money they have. So amount of money. Now, because I'm making these class level variables, it would probably be best if I went ahead and gave them an initial value of 0 so that I don't get any sort of error messages when I try to use them. It's not the end of the world, but I'll go ahead and put that in. So let's set them equal to 0. Now, I want to put the call to find out how many downloads they want and how much money they have before the display output, right? Because I can't display the output until I have the input. I've got to get the input before I can display it. So right after we call our input string, let's call, oops, our input int. Now our integer that we're going to save that data in is going to be our num downloads. And I'm getting one of those silly ears. What kind of thing is it griping at you about?
An object reference is required for a non-static field.
It's silly static again. So again, since this variable is going to be used by a static method, I have to mark it as static. And then my error goes away. And we're going to look at an illustration of that in just a moment. So our amount of money is going to be equal to our input double. Now with the call to our display output, since our fav band variable was local, I had to pass it as a parameter to our display output. Since our num downloads and amount of money are global, I'm not going to have to use those as parameters. I can access them in all of the methods that are within this class. So I will go ahead and in my output, add that information. Let's see, what do we want to have? We want to say, you would like that many downloads. And then you have that much cash to spend. And the variable that we would like to use is, oh, what's it? Wasn't there some way that I could format that as currency so it would have a $ and be all pretty? What? What is it? 0:C. You are so right. Good job. Okay, let's see if our program is all working here. I'm going to control F5. Who is your favorite band? I want 15 downloads. I want to spend $35.67 because I made that a double and I'm going to use it. Ah, there we go. Favorite band is Green Day. You would like 15 downloads and you have this much money on hand. Is it working for everybody? How's it doing?
It didn't work.
Didn't work for you.
Help each other. Let's get it all working. We can show it on the screen too. Oh my goodness. Line 24, it says. Okay, go ahead and run it again. Just make sure you type in your So I don't think that you You're gonna have to do some research and see what's going on.
All right, gotcha.
Are you guys doing? Are you okay? You sound like you're sick. Are you sick or allergies? Allergies? Did you get this early spring? Okay, so
Let's keep this one and we'll use it as we go. So I'm going to save all. I think everything's working the way I wanted. And I think that I'm trying to find where this PowerPoint is. It may not actually be on Canvas, so I will get it out there. And I apologize, right now we seem to have we're kind of backwards with our lab time and our lecture time. We'll get it switched back around. Just happens as we go. But we were looking last chapter at methods, and keep kind of skipping a little bit, like if statements and loops and things. Like I said, I want to get this structure down first. You can't decide and paint the house until you have it built, right? That's the same thing with C#. We want to understand how everything is structured, and then we can put it all together. In chapter 5 in our textbook, they talk about encapsulation. Well, these are pictures of encapsulation. Encapsulation, sometimes when we're talking about software development, we might not think about what a term actually means. But right here,
I like this one. This is some sort of anniversary gift somebody got, and it's got some earth and grass encapsulated in this, acrylic block. Then over here, I've got a piece of paper, some sort of printout, and I've got some of those sticky laminating sheets. And so this piece of paper is going to be encapsulated within those laminated sheets, right? It's going to be stuck inside of there. Here's a really good picture of encapsulation. This is a smartphone. And if you look at the smartphone, all of these components, circuitry and screens and electronics that make this work are encapsulated within the case so that we don't have to worry about any of those things, right? We just worry about the interface that we use and turning it on and turning it off. So important. So this is the program that I asked you guys to put together. We had 1, 2, 3, 4, 5 methods plus our main, and our main being our kind of controlling method that called all of the others, made them work together. So I wanted you to try at first to kind of jump in, and they say that if you jump into something and you let your brain come up with questions and realize there's some gaps, then it is better at absorbing information as it goes. We'll see. But here was your display instructions method. I just made it really small because what we're focusing on here is how to make the method. So everybody has come a really long way. We know that that method is that logical code block. It has its name, which is also called its method implementation. And the body comes within the opening and closing curly braces. So that code is encapsulated within that method, right? If I want to display the instructions there, I can call that method and it'll take care of it. I don't have to worry about it anyplace else. All of this has all of those same method things that we've looked at already. When we want to call the method, we just put its name in our code. And our method can be thought of as a black box. That's what method encapsulation is. So when I call that method, I don't have to worry about what it does. I can just call it, let it do its thing, and it's going to return to me some output. One application that I always kind of like to equate to the black box thing, when I worked at Conoco a long time ago, I had a friend, she was also from Southwest Missouri, who worked there too. And they assigned her to write the software to calculate how much oil or fuel or whatever is remaining in the storage tank. And if you look at a storage tank and you drive down the highway and you see a whole bunch of them, you don't really think about it that much. Well, the storage tanks are built to pretty exacting, I guess, standards, but yet they're really dynamic, they're really flexible. So they can actually kind of move around, and the top has a giant piece of metal or cover that sits on top of the oil. And then as the quantity of the product goes down, that cover kind of drops down with it so that there's not air. You can't have a big old giant storage tank of jet fuel with a whole bunch of air at the top. So they have lids. So they have all these really weird things, and the sides will get kind of bendy, and the engineers will keep all of that. They'll account for all of that when they're measuring things. So it's very interesting. So Jennifer had to do a whole lot of work. She had to work with the engineers for 6 or 8 months, and engineers that would go out and measure storage tanks and go inside and drop down their little stick to see how deep the gas was or the oil. And it was a very, very, very involved task. She would write code, they would analyze it, determine if it was correct, come back to her and say, no, we're off a few gallons, we need this to change. So this is something that's really important, right? It's all their money. So once she got that code done, do you think they ever went back and said, let's rewrite that? No, not unless there was some sort of major undertaking or major problem where they redesigned storage tanks completely. So Jennifer wrote this black box. How much product is in this storage tank based on the tank name and the measurement, right? You can go look up all of the information about it. So it's a black box. Nobody else has to go through all of that trauma to work with all of those engineers to figure out how to do those calculations, how to come up with that formula, all those algorithms, because it's done now.
Now, that doesn't mean that it can't be improved. You guys, as you see, there's always room for software development for improvement. So that's good. We're never, ever all the way done. But that black box idea is really important in development. Because if we were constantly redeveloping the wheel, constantly figuring out another way to do the same thing, we'd never get anything done. So we have to get some things coded, put aside, and black boxed. Now we can call it from wherever we want and use it. Now, how does a method encapsulation work? Well, pretty much just like that. We have our input parameters that come from outside, and we have our return values that are sent to outside of our method. But within our method, we can have private data fields. We saw we could have those specific variables in our method that are hidden from any other method. And we could have the algorithm, all of the logic that goes on in that method. And it's all hidden from anybody outside. They don't have to worry about it. All they need to worry about is what's the input and what's the output for that method. Okay, and our static keyword only occurs once. So whatever we mark as static only occurs once, like display instructions. Our main is a console program, right? We say we want this to be a console program. In the old days, when things were first developed, there was one console. That was it. There was just the one. So anything that was going to be input from or output to the console had to be single threaded. Could only do one thing at a time to display messages on that console. So we had to have this idea of things being static. There only being one of them. There's only one console. And then we saw our access modifiers. We used private, and I said private means that no other class code could get to this method. Well, if we made it public, then we could share that code. We had other programs somewhere that wanted to use it, they would be able to. And protected and internal give us a little bit more security than public, but they get to have more meaning as we write more advanced applications. Finally, we saw that as for input to a method, we can have a parameter. If we have multiple parameters, we're going to separate them by commas. We don't really do that in our program, but we always have lots of opportunity for practicing. And last time, we were talking a little bit about overloaded methods, where I can have multiple instances of a method with the same name with different signatures. So different return types or different parameters. And the C# runtime system will determine which version of the method to run based on how the method is called. And that gives us the ability to have our method do multiple things. We'll look at that a lot. Okay, so why is a method part of encapsulation? It hides the details. The other people that are using our method don't need to know how to calculate a storage tank volume because it's acting as a black box. So methods help us implement these modular programs where we can have one person do some work and other people use it. In each method, we want to have a function, a logical reason for being. And this is really going to help us make our code reusable and make it more understandable and maintainable. Okay, we're going to start on really object-oriented things. So I want to show you this program here. So this is a Unity program here. And it's a sphere emitter. So we said that all of the things that come from the main or that get called by the main have to be marked static. So if I have the word static, I can only have one thing. So I can't do this. right? I can't have all these spheres because if I had something marked static, I would only be able to have one of them, right? So I could have my sphere emitter, it could be static, but all of the spheres that are being emitted, they can't. They're not static. Whenever we're working with object-oriented ideas, each of these spheres is going to be considered an instance. So they're an instance of a sphere. For each instance of these spheres, I'm going to be using like some sort of blueprint or model, right, to decide how the sphere gets generated. That's what we do. So we're going to have some sort of model. Now in my model for a sphere, what kind of data could I or use for each sphere? Color, size,
Acceleration. Collision boundaries.
so a collision would almost be kind of a state, like has it collided with something? But yes, that would be something we want to keep track of.
You want gravity?
Do what?
Gravity.
Gravity,
Mass.
mass. So all of those physics, we'll put physics, all of those kinds of physics things. Good, because those are the kinds of attributes that I would have for each of these spheres, right? So all of those, we could consider those to be our data about our spheres, our attributes, our properties. So I'm going to try to think of the 47 terms I could use for all of these data elements. Are they making a pile? Oh, they got to go inside with it. So the physics is really cool, right? Because they're just because they're affecting each other, you kind of change the way they're all going. Okay, so that's great. Those are data attributes. What about behaviors? What kind of behaviors are you seeing out of the spheres? What kind of methods would they have? I guess the first one to me would be the one where we create a sphere, right? So that would be the instantiation, our big word for today. So instantiation is when I create an instance of something. That's when I instantiate it. What other kinds of behaviors are they doing?
The visual warping of the sphere based off of where it's in comparison to the camera's perspective.
So what could I write down now? Warping? Let's do that.
It's almost like a panoramic sleeve.
Yeah, I'm not sure. I'm like, yeah, but I can't write that down. So those are good.
Flat. All the balls coming on a flat line. So what we're seeing, the warping is actually like a panoramic camera of balls.
Kind of watching him.
Because none of them are falling forward or backward on that block. They're all so they're all on a straight line. Like a flat wall.
It's really interesting. Just watch it. 'Cause there's, sometimes there's like no yellow ones.
I think some of them are coming forward.
No, I think that's from the warping the panoramic view. It's like
Well, so would I need to do that? Don't I need to be able to do that? Set their color? Should I be able to set the color? Do you think I can find out what color they are from them? Could I get their color? Can you tell me what color you are, sphere? What about, and so I could do these set and get type things for all of these different attributes, right? Tell me, sphere, what size are you? Tell me, sphere, what acceleration are you? What direction are you traveling? I could get all those things. What about if they collide with something? I'm gonna have some sort of collision event here. What do I do? Do I just go the other direction? Is there something happening there? We could make something happen. Like right now, maybe there isn't much happening, but maybe I want to, you know, instantiate some sort of explosion or something, make one of them disappear. I could do things like that. Whenever. There they all go. So I could explode. I could destroy one of these objects, right? Make it go away. You'll see if you were looking at Inspector, you'll see that doesn't happen, and there's just billions of them piling up, sucking up all the RAM on my machine because they're not destroying. So they're going to get slower and slower and slower as they try to stay alive, and they're actually dying.
It'd be cool to make like a maze for them to fall when they're in.
They're very neat. I like it. Okay, so all these are super important. So what we found is that for any object that we want to code, we're going to have certain things that we need to be concerned with. We're going to need to be concerned with the data that object carries, the attributes, and we're going to be concerned with the behavior of that object, and the behavior is going to be the methods.
So as far as the viewing program goes, can you like angle it where you're looking straight down to the column? Because I mean, it's already slow just looking at it, and we're no longer seeing the visual aspect. But I'm curious to see like if it just annihilates it.
I don't know if I can. Let's see. It doesn't have much stuff.
If you got a scene, you should be able to angle the camera.
Because it's not even showing it to me. Where are you, stupid camera? I don't know. My camera's like hiding. Where are you, camera? I don't see the camera. You guys will have to mess with it here in a minute. Let's get these notes down first. Try to get me distracted. I see how you are. Okay, so notes, 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 things that we need that are really, really important for object-oriented development. We're seeing that for every instance of an object we create, we're going to be instantiating that instance. That instance is going to be based on some sort of model that we've already supplied. That model is going to specify what kind of attributes this object has and what kind of behaviors this object has, so that we can kind of, in our programming, be able to keep track of multiple instances of something instead of just one. So with the program that we wrote today, we can ask one user for one favorite band. But if we were to take that and make it where we could keep track of people's responses as objects, like their audio answers or something like that, we could keep track of multiple people's responses. The way we are right now with our console as our input or output, we would still be single-threaded on that. We're still only going to be able to ask them one question at a time. So we're going to keep all of our user prompts kind of in our main, and we're going to take all of the information that we're gathering from our user prompts and create objects. So whenever we create a model in C#, that model is called a class. And we've already been using classes. We've just been putting our code within the main method of our program class and keeping it all together that way. So next time we'll split things up a little bit. Start looking at that chapter 5 in your textbook. They have some really good examples working with a car we'll work with some of those examples next time, and we'll get started looking at your REPL for this week. You don't need to look at it until next time though, because otherwise we won't quite be ready. Questions?
Now, if we look straight down on
Do what? Yeah, come fix it. I'm just gonna, you come take over. Couldn't find the stupid camera. I get all the way. Do you see this? I mean, I see the camera over there, but it won't go to it.
We have all of this right here. I don't know much about Unity.
No,
You know
see, because
Unity,
it should be.
Yeah,
Pretty
Go to
Jacob
scene.
does. Okay. Oh, well then, duh, there's my
And then
problem.
click on that.
See, I told you I don't do good when everybody's watching me.
And
Can I just change mine?
go to rotate.
You want me to just
Yeah.
rotate it?
That's what I do.
Okay. Go ahead and rotate it. Because I'll make it where you can't even see anything.
Oh.
He's gonna fix it. I like our book for the Unity class because it says things like, as a developer, you don't have to worry about the interface. And I'm like, that's true.
Come on.
See? I was just gonna gizmo it and make it go other direction. Get these experts up here. Come on, experts. Drag it, fix it. Should be easy.
Yeah.
That's a lie, like -7.5.
Oh, okay, that worked. $7.25 is what he was suggesting. Nope. You guys are all so easy.
We want to look down, though.
I think you just change the gizmo thing. Click on that. Blue.
Oh yeah. Oh yeah.
He's getting there. How many people does it take to move the Unity camera? A lot.
Come on. Move it forward. Down. Yeah.
There you go. Woohoo! Yay.
All to just crash the
There it goes.
Let's see.
Okay, you guys wanted to just see this. It's going to make you sick. Going to make you seasick. Actually, it's kind of weird.
You can see the pixels going crazy with this and trying to track the really far. Is there actually a bottom to this, or is this just like?
No, it's infinite.
It's going on into space. So
So then how many balls are there?
I want to watch the hierarchy screen so you guys can see the spheres get created. There they go. You can tell that it needs more RAM. Can see it. Okay, think about objects. And like I said, in your textbook, they talk about a car, but we are set. If you need to finish up that REPL, do so. If you need some help, let me know. But other than that, you're good to go today. Get back here. Any questions? Got it? Okay. It looks like a, I don't know, like a superhighway.
Yeah.
Two superhighways, like they're heading up in their different directions for stuff. You do.
A screensaver really slowly crashes right here.
Under the desk or something. We're gonna be here for hours.
Be able to handle it. We can do it.
I know this is great. Purchase and
You definitely want to have it where that like deletes the object. Search for it.
I was wondering about some factors.
Yeah, it says like convert into string. I'm like, what am I converting?
So we're just in this one.
I know, I was looking at my son, other side. Is it small? I was gonna put it in two separate lines, because I was like, yeah. So we'll start. This one is dry, I'm not saying.
Not a really great.
I never know which way it's gonna have. I'm turning it off, so I don't throw it.
It was crazy last night, like right after the Super Bowl ended,
Uh-huh.
power went off.
Oh, no.
It didn't come on until like 5:30 in the morning.
Really? So do you know what it was? Because I saw somebody post on Facebook that their power was out. I don't know if it was.
He was on like me and like the house behind me. All the other houses.
Really? We thought it was funny, all the fireworks. Did you hear fireworks? There was like more fireworks than New Year's Eve. So,
That game was crazy.
well, we just turned it on at the very end, so we liked it 'cause it was real exciting right there at the very end.
They
It
were
was
like,
like,
"Are the Chiefs gonna win or what?"
yay! It was super exciting. I don't think it could have been any more
So when the power came back on, I have an older Mac,
Uh-huh.
and it has like a built-in speaker. So the Mac turned on, it was like boom, and made the startup sound, and my like monitor turned on. I was like, okay, I guess time's back on.
I'm glad at least it came back on before you had to go to school.